Hello everyone. Today's topic is center of gravity. Knowledge of this topic helps us balancing the objects. For understanding center of gravity, let us consider this irregular shaped object. Every object is made up of so many particles. Each and every particle has its own weight, which is acting in vertically downward direction. Weight is nothing but the force with which the particle is attracted towards the center of earth, right? Now, if I add up weight of all the particles, then I will get the weight of whole object, right? The question is, at which point is this weight of whole object acting? That point is called as center of gravity. What is it called as? It is called as center of gravity. Weight of whole object is concentrated at this point. Now, let us try to understand it in different manner. I am fixing this object about this point, right? Then, weight of all these molecules will tend to rotate this object in anti-clockwise direction, right? And weight of all these particles will tend to rotate the object in clockwise direction. Now, this point is located such that about this point, anti-clockwise moment produced by these particles will be exactly equal to the clockwise moment produced by these particles, right? So, your object will be in balanced condition. Clear? Now, if I add up the anti-clockwise moment and the clockwise moment with a sign, right? Then I will get the sum 0. Clear? So, about this point, that is about center of gravity, sum of clockwise moment and anti-clockwise moment will be exactly equal to 0. This is an imaginary point which exists within all the particles and all the objects. So, definition is, the center of gravity of a body is the point about which algebraic sum of moments of weights of all the particles constituting the body is 0. The entire weight of the object can be considered to act at this point, howsoever the body is placed, right? So, weight of whole body is concentrated at its center of gravity. There are 3 important notes. First one, the position of center of gravity depends on its shape. Let us understand this with example. I am taking a wire, grey colored wire. Where is the center of gravity of this wire? Here, right? Now, if I turn this wire into a ring, center of gravity is shifted. Center of gravity position depends on the shape of the object. Same wire converted into a ring, but the position of center of gravity is different. That truly depends on distribution of mass of particles in it. Clear? And center of gravity changes if the body is deformed. That is, if you change its shape, definitely its center of gravity will shift. Second note is, it is not necessary that center of gravity always be within the material of the body. Not necessary. We have seen the example of a ring. Material of the ring is grey colored part, but center of gravity is in air, right? So, make sure it's not necessary that it should lie within the material of that object. Clear? The same is true for hollow sphere as well. Third important notice, by the concept of center of gravity, body of weight W can be considered as that point particle having weight W. Next is center of gravity of some regular shaped objects. Let's take one by one. First is rod. Midpoint of rod, yes, circular disc, geometric center. For hollow sphere or solid sphere, geometric center of sphere. Solid or hollow cylinder. For cylinders, we need to draw their axis, right? So midpoint of the axis of cylinder, right? For a solid cone at height h by 4 from the base on its axis. For cone you have to draw its axis, and h by 4th part from the base lies its center of gravity. For hollow cone you have to draw its axis, then divide that height into 3 parts, then h by 3rd part from the base lies its center of gravity. Then for circular ring, just now we observed was center of the ring. Triangular lamina, if we consider page of our notebook, then it is having length and breadth, but thickness of the paper is negligible compared to length and breadth. So as thickness is negligible, we can say it's a lamina. So all the two-dimensional objects we call them as lamina, right? So a triangular lamina or a scalene triangle. Point of intersection of medians. Parallelogram, rectangular lamina, square, rhombus. You have to draw two diagonals. So point of intersection of diagonals will give you center of gravity. Let's see center of gravity of some regular shaped objects. Circular ring, geometric center, then circular disc, its geometric center, then triangular lamina. So we have drawn here 3 medians, and intersection point of medians gives you center of gravity. Then rectangle. So we have drawn diagonals, intersection point of diagonals gives you center of gravity. Then we have a parallelogram. Again intersection point of diagonals gives you center of gravity. For square as well, intersection point of diagonals. Then for a rod or a wire, means cylindrical shaped objects. So we are having it as midpoint of the axis. Then next is a cylinder. So see, clearly we have drawn here axis. Midpoint of the axis of the cylinder gives you center of gravity. Now center of gravity and the balance point. This is a very important topic. When a body is pivoted, at its center of gravity lies above the point of pivot. So wherever the tip is, right, just above that if your center of gravity is, then this object will be balanced, right? If you are keeping this pivot such that it is little bit this side or that side, then definitely you will either get clockwise or anti-clockwise turning effect. But if you want it exactly horizontal, the point of pivot should be exactly below the center of gravity. Clear? Next, we are taking this cube, right? We have pivoted it. So point of pivot should be just below the center of gravity, then and then only the object will be balanced or in equilibrium. Next is, if you suspend an object, that is, this is a rigid support, and with the help of a thread we are going to suspend 2 objects, same 2 objects which we considered in previous slide. I have suspended them, tied them up with a string, right? Then point of suspension should lie just above the center of gravity. Clear? Point of suspension should lie above the center of gravity. Then your object is balanced. If little bit here or there, if you have tied up string this side, what will be the observation? Definitely this rod will be turning in clockwise direction. So you will get clockwise moment. If your string is tied up this side, then we will get anti-clockwise moment, right? So make sure if your point of suspension is just above the center of gravity, object will be in equilibrium. Till now we have discussed only about regular shaped object, but there are so many irregular shaped objects we come across, right? So how to determine their center of gravity? So let's perform a small experiment. It's an irregular shaped surface. Now I have made 3 holes, A, B and C. Okay. Now I have suspended this lamina from hole A. Along with this lamina, I have suspended a plumb line. What is a plumb line? Plumb line is used by mason on construction site for building a wall. They use this for checking whether the wall is exactly vertical or not, as the pointer of this plumb line points exactly towards the center of earth, right? So this string will show you whether is it exactly vertical or not, means perpendicular to the earth's surface or not, right? I am going to draw a line on this lamina along the string of this plumb line, right? So from point A along the plumb line string I have already drawn a line. Now I have suspended this lamina from point B, and again I am going to draw a line along the string of this plumb line, right? Because I want exactly vertical direction, okay? Now from point B I have drawn a line along the plumb line, and same procedure I have repeated for point C, that is suspending from point C, and I have drawn a line along the string of the plumb line. Intersection point of these three lines gives you center of gravity, right? In this case, center of gravity is lying exactly below the point of suspension. Next, important note, for stable equilibrium, this is going to help you out in your day-to-day life. For stable equilibrium of a body, means if you want to balance a body, then its center of gravity must be as low as possible. So you have to adjust such that its center of gravity is as low as possible. Now let's take this example. This kind of a toy you might have observed, right? If you hit this toy, it's going to move here and there, fluctuate, and then again it will come to rest in its original position. If you might have observed carefully in this toy, there will be some sand particles filled in its base. Why? So as to lower down the center of gravity so that it can get balanced condition again and again, right? If we apply force, if we hit this toy, yes, then we will be getting clockwise and anti-clockwise turning effects, but as center of gravity is lowered, it will come back to its equilibrium condition. Clear? One more example for this is buildings, high-rise, tall towers. They are constructed such that their foundation base is made wide so as to lower down the center of gravity so that the object will be balanced, right? Thank you.